IP addressing, and we're working with IP version 4. If you are reviewing for certifications or planning on taking your first certification test, more than likely class will be reviewed in some way on your test. You'll be questioned one way or another. So we're going to go ahead and start going over the classes associated with IP addressing. Later on, you'll find that there'll be masks used that accompanies the address so that you can look at the mask and tell which portion of the address belongs to the network, which portion is reserved for the host. Starting with a Class A address. On Class A address, one of the rules that you can go by is the binary address always starts with a 0. Knowing this, we're going to write a little 0 right here. I'm going to quickly write out our chart and use this chart throughout all the classes. We all know it by heart: 128, 64, 32, 16, 8, 4, 2, 1. If a Class A address, the first bit is always turned off, to find the minimum address, then we would simply turn off all of the remaining bits. In doing that, we actually come up with 0 as the first address. Note, we can't use 0 as an address. It's reserved for default routes. Knowing that it's reserved, we can't use it. Our first available network in a Class A is 1. Now, let's go ahead and get the maximum number. To do that, let's turn all the bits that remain on. Again, keeping the first bit turned off because that's a rule in a Class A address. If you do that and you add up all the values, 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, you actually get 127. 127 is also a reserved network address. It's actually reserved for what is called loopbacks. Which is used for internal testing on the local machines. That means 1 to 126 is our range of networks for a Class A address. An example would be 168, 212, 226, excuse me, I didn't write down the beginning, 102, 102.168.212.226. If you look at the first octet, it falls within the range between 1 and 126. We know, because it's a Class A address, that the 102 represents the network portion. The other 3 octets belong to the host. So these numbers will change. 168, 212, and 226 will be unique on each device within the network. 102 will be the portion that always remains the same on each device within your network. Moving on to Class B. It starts out with a 1 and a 0, always, in the binary portion. So let's go ahead and use that rule. 1, 0. To get the minimum number, what do? We turn off all of the remaining bits. So we're going to turn off 32, 16, 8, 4, 2, and 1. Look at what we have. The first bit by our rule is always turned on, so our first value is 128. Now, to get the maximum number, let's turn all of the remaining bits on. If we add up all of the bits, it would be 128 plus 63. That would give us 191. An example address for a Class B address would be 168.212.226.204. where the 128 and 212, that represents the network, and the 226.204 represents the host. So the network portion will remain the same. It will not change throughout all the devices, but the 226.204 will change for each device. Class C address. The rule for it is 110. So we turn the first two bits on, and we always have the third bit turned off in a Class C address. If we look at it in binary, we turn off all the remaining bits, and 128 plus 64 is 192. So that's our first available network address in a Class C address. Let's see what we can go up to. Let's turn on all of the remaining bits. So if we add 128 plus 64 plus 16, 8, 4, 2, and 1, that would give us 223. An example IP address for this would be, let's say 200.168.212.226. If we look at the first octet, we see that 200 falls within our range. That means it's a Class C, which tells me the first three octets is the network portion. The last octet is the host portion. Class D, it starts with 1110. If we work it out, we would find that 224 to 239 would be our range, and these are reserved for multicasting. So you would not be using these to assign in your network. Along with Class E, the rule on it is you turn on the first 4 bits. That would give you 240 through 255. These are also reserved. These are reserved, they're used for experimentation, and they have never been documented or utilized in a standard way. So Class A, Class B, and Class C are the classes that you'll be looking at in order to apply them to your networks. This is where we're going to begin.